Alright, on the trick bite, which ones did we want to see? Go over, have questions about, maybe we just go check the answers. Were there any others that we wanted to double check? Go over the answers. 4. And I heard 5.
Check it out. That's OC, bro.
Alright. Everyone's attention. Waiting on everyone's attention. Start with anime. Alright, we're going to go over 2, 4, and 5. 2, the order of operations you would do what's on the inside first, so these parentheses. You do some of this stuff at the same time, but if you did everything once at a time, that's fine. You could have also changed this exponent, or you can wait till you do it here, it doesn't matter. So change this to 64. 2 to the third was 8. If you weren't able to get to the third, you use this little button here, and that'll bring it up. And then that became 24 minus 64 plus 32. Whether you did this all at the same time or once at a time, it didn't matter. This would be negative 40 plus 32, which was negative 8. So if you got that, good job. If not, fix it.
Did you get that?
Questions on that?
Wait, what?
Other questions on that one? For number 4, we needed to first distribute. So this would be plus 14 plus 21b equals 82. Then we could combine like terms to do exactly what it says. Negative 4 plus 21, so 17. B plus 14. Then we could just solve. Get rid of 14 by subtracting. And divide. Questions on that one? And then 5 was also a solving one. We need to get rid of the 8, so subtract first. Get rid of the negative 4 by multiplying it on both sides. And this would be positive. Questions on either of those? Gianna, did it go through? Alright. So, a couple things before we'll start the notes afterwards. That I wanted to mention, talk about. One, some of you have been taking advantage of the e-hall passes. So, moving forward, starting today, when I look at your passes, if your time was over 5 minutes and it wasn't a me thing, like I forgot to end your pass or whatever, I'm writing you up for skipping class.
5 minutes?
So,
taking like 10,
some of you are going down to the commons, going downstairs, not going to the bathroom. Go to the bathroom and come back.
Yo, 5 minutes, bro. Yeah, I'm gonna get rid of those.
Questions on that?
thinking like 7.
Because some of you already abused the 7. Now, if you have like somebody confused with something, that's different.
I'm not thinking chocolate.
But that's not going to be at every class thing. Okay.
Well, he's always got it.
One.
Damn, 5 minutes.
Okay. Something else. Some of you, most of you, are not coming to see me after school to get help. And it's showing on your quizzes, on your tests, on your grades. So many of you, starting tomorrow, because it's not after school day, if there's something you're not understanding as we have quiz and test next week, you should be after school tomorrow. Or if you have work, I get it. But come see me. I can work something out with you. You need to start coming to see me more often. There's really no reason why any of you should be failing this class, as long as you are practicing inside and outside of this class. So we're going to try and do better. We're going to come see me when we have questions. I'll wait. So we're going to come see me when we have questions about whatever. We are actually going to do our work, because that's a big part of it. And we're actually going to do the work inside of class and outside of class. And then we'll talk more about that when we get back. As I was mentioning before lunch. So I give you guys a lot of time to practice after our lessons, but many of you do not utilize it well. So you get your phones back 5 to 10 minutes or 15 minutes, depending on how I feel, towards the end of class. That way you can actually use this time to practice and not be doing other things. Do we have any questions about what you should be doing moving forward? What you should have been doing, but what you should be doing if you haven't. Okay. Last thing. Call this an incentive. Because I know many of you do not do your Delta math as you're supposed to, even though it would help you, if you did, to prepare for the quizzes and tests. If you do your Delta math, so when I check them, so like today I'm going to check them, they're usually assigned to be due on a Friday, or in this case, tomorrow. There are some due tomorrow. So the ones that were due last Friday were the graphing and the substitution. If I go into this, and these numbers, the grade or the completion numbers, I know it's a little hard to see, says 50%, that means all of you did something in this and completed at least 50% of the assignment. I have a gumbo machine, and you can all get a gumbo. If you get it to 100, you're already late.
Yeah.
Come in and be quiet. Thumbs up.
I don't even got one.
Great, you put your phone up. Wilbur, did you put your phone up?
Which was one?
11. So, if you get this to 50%, you get a gumball. If you get it to 100, you get 2 for every assignment. So, if you all do your work, I have comfort. But if that's not something you're interested in, your grades will continue to look like this, where 1 or 2 people are doing their work. So, if I go back, this one's better than the other one, but still very low. Many of you are not doing these math. So, next week, when I check this again, if your elimination is everyone should have notes in front of them. We're not going to do this entire packet. We're going to go through some of them. The rest is for you to practice. So, as a reminder, in our systems unit, we've talked about how to solve systems by graphing, how to solve systems by substitution and elimination. What's nice about the word problems is that we kind of already know how to set them up because we talked about it before. So most of them will be set up the same way. But the ways to solve it are the ones we already talked about. Graphing, substitution, elimination. You're not learning a new way to solve it. So as with any word problem, let's read it first and then find any important information. So you can either read it on the board or with me as I do. Alright. A snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos costs $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. What do you think is important in this? I heard different things. Okay. Okay. And then you said something. The total, the 220?
Yeah.
Okay. I heard some other things. Say that again.
60 packs.
The 60 packs, okay. And then what was it? Okay. Anything else we feel is important? So L is the number of large nachos, S is the number of small nachos, and what are we looking for? How many large and small packs of nachos? That is what we're looking for. Please, you have a question?
No.
Okay. So, because we are comparing two things, almost all of these are going to look like the format AX plus BY equals C. Something we've talked about before. We're comparing two things, we put them in this format. Now, in this case, we are given two variables, L and S. Those are going to be like our X and Y. So if you want to change them, you could. You could also leave them. It doesn't matter which one you make L, which one you make X, which one you make Y, as long as you're consistent. Just as we did before, whatever X, or in this case L is, A has to be connected to it. Same thing with B and Y. So we have a variable talking about number of, we have something else that talks about large nachos. So we're going to put those two things together. 5L or X plus, because of our equation, what would be the next part? 3S. I'm going to change the color of my S because my S is in 5s. And then what would this equal? Now, this is one of our equations. We're dealing with systems, so we need another. So we've used almost all the numbers that we've highlighted. We use the variables, we use the 220, we use the 3, we use the 5. But now we have this other number, this 60. That's going to be what this equals, the second equation. 60 represents the total number of nachos altogether. What else is about number of nachos? What else was given to us that says something about number of nachos? L and S. So those are going to be part of your second equation. So we'll always need two equations because we're dealing with systems. It's still set up in that ax plus by equals c format, but in this case we just don't have an a and a b. Right? Also, something to remember, if you see 1, 2, 3, 4 numbers, it's most likely going to be set up like this. Right, now we have options. We have our equations. I skipped a step. Normally, you would write off to the side what your variables represent. So we didn't do that because they defined them, but I'll do that just so that you have it. You would be specific with this. L is the number of nachos, as it said, or small, not large, whatever. I just shortened it. So L would be the number of large nachos, S would be the number of small nachos, or packs of. So you would want to do that for all of your work problems, just to define what does this variable mean, what does it represent. But now we have two equations. We can either solve this by graphing, by substitution, or by elimination. I'll let you guys choose. Elimination. Okay. So the thing about this is we have to keep in mind, how do we do elimination? Elimination, we have to make sure that one of these variables has the same coefficient. Right now they do not. We need to make that happen. And then eliminate one of the variables and start subtracting. So because it asks for both, it doesn't matter which one we do first. So do we want to eliminate L or S? S, sure. So we need to make these the same. Right now this is 1, invisible, but it's 1. So to make these the same, I would multiply this entire equation by what? To make it the same as this? 3. So I can multiply this entire thing by 3. So we change this. I'm going to rewrite the first one and write the new one. I skipped the S because I'm writing in a different color. Okay, make sure you multiply the 60 as well, because if you don't, things get funky. Okay. Now if we wanted to eliminate our S's, would we add these two or subtract them together? Subtract. So we have 2L, those are going to become 0. 220 minus 180 would give us 40. Nico, close out. And then when we divide, L would equal 20, but because these are word problems, just like before, we need to label, so 20 what? Large packs amounts. Or not large amounts either. Okay. Alright, and then we have to go back and find S. You have choices to put this back into. I would probably just do this one. So I know L is 20. I'm looking for S. So if I were to solve, S would be what? And again, labels, small packs of nachos. Some questions will ask you to just look for one thing. Some will ask you to look for both. So it depends on what it's asking you to look for. Do we have any questions on any of that so far?
I mean, it looks like
Alright, for example 2, we're going to set this up, but we're not going to solve it, and then we'll move on to example 3. So go on to the next page. Let's read through that. In a talent show of singing and comedy acts, singing acts are 5 minutes long and comedy acts are 3 minutes long. The show has 12 acts and lasts 50 minutes. Let C be the number of comedy acts and S be the number of singing acts. Write a system of equations to model this situation and determine how many comedy and singing acts there were. What's important here? 5 minutes. What was 5 minutes? Singing acts, okay. Comedy acts are 3 minutes. The show has 12 acts and lasts 50 minutes. Wilbur, find something important from this. What is the question looking for?
Number of comedy.
Is that all?
I think so. Comedy and CD.
There we go.
Oh.
And then 2 other things that are important here. The number of singing acts, and we have those as variables already. S is the number of singing acts. C is the number of comedy acts. Okay, so again, still 2 different things set up the same way in that AX plus BY equals C. But in this case, we're going to use C and S unless you want to change it to X and Y. How would we set up one of these equations? So back to example 1, if need be, look at the numbers. It would be similar, different numbers and letters, but how would I write it? It's going to be in that format, but our variables are now C and S, and we have numbers in here. S plus 3C equals 50. Equal what? So if you're not sure which numbers go with which, the 5 is talking about minutes, the 3 is talking about minutes, 50 is talking about minutes. All the minutes have to go together. And the last one, all the money went together. The $5, the $3, the $2.20. So whatever there's 3 of, put those all together. How would you set up this last equation? S plus C. So again, we're not going to solve this one. I just wanted to set it up so that you have the foundation. Go on to example 3. Right. Christina went to the mall and bought 5 pairs of earrings and 2 pairs of shoes for $30. Each pair of shoes costs 2 more than 4 times the cost of earrings. Let E be the cost of earrings and S be the cost of a pair of shoes. Write a system of equations and model the situation and determine the cost per pair of shoes. What's important? Maybe she got them on sale. What's important here? Right. More than 4 times, or Or you heard about this one?
Yeah.
Two pairs of shoes for $30. That's the. What else?
Each cost costs a lot more than the.
Okay, so that basically then higher sentence. What else? 5 pairs of earrings. Total of which is what? 30. And this is total for everything. Right. And we have our variables. And we are looking for what? Alright. Now, this one's a little different because of this sentence. This is going to be set up just like before, but this one's going to be different. So let's set up this one. How would I set up this equation? With the 5 pairs of earrings, the 2 pairs of shoes, and the $30. 5e plus 2s equals 30.
Yo.
That each pair of shoes costs $2 more than 4 times the cost of earrings. So if I knew the cost of earrings and I whatever more than did that to the cost of earrings, multiplied it by 4 and then the more than, I would get the cost of shoes. So I'm going to say that E equals, so let's set up the equation. 2 more than 4 times the cost of earrings. Sorry, not E. This should be S. My bad. How would I set up this equation? How would I say 2 more than? 4E plus 2. I'm multiplying, guys, I need you to be quiet. I'm multiplying the 4 to E, 4 times the cost of earrings, plus the 2 more than, we're adding 2. So the last one we solved by elimination. We could have did any of them. This one has an equation where we have a variable by itself. Which of your 3 methods is really good for that? Graphing, substitution, elimination. Substitution. So when you have something like this, I have an equation that's already solved for the variable. I'm going to take this piece, put it into the other one where S is. Thinking back to how we solve substitution. So we would rewrite this. 5e plus 2 times whatever the equation for S was equals 30. Just as when we are substituting, if you substitute it into the wrong thing, you'll still have 2 variables. If you still have 2 variables, you know you did it wrong, incorrectly. We only have 1 variable here, so we can solve for E and then go back and solve for S. So we can distribute combine like terms. 5 plus 8 will give us 13. Subtract 4 on both sides. And divide. What is the cost of earrings? $2. And that would be our label, the dollar. Okay. Now we gotta go back and find S. So we can put this 2 back in this equation where S is. solve for S. So we'd have 4 times 2 plus 2, which would give us what? 10 what? What's our label? Dollars. Not throwing things. Do we have any questions on how we set those up or solve them? We are not going to do example 4, but if you look at it, it should look very familiar from something we've already talked about. I do want you to find this page. So there's a maze in there. It just has a bunch of problems. You can solve those with number 2. The last type of equations we need to talk about are these different wind and current, like river speed problems. So we'll do 2 of these and then you'll have time to find this. Alright, so for number 1, let's read that. Flying with the wind, a plane went 369 miles per hour. Flying into the same wind, the plane only went 325 miles per hour. Find the speed of the plane in still air and the speed of the wind. What's important there? You guys said 2 different things. Say that one more time. 369 miles per hour. What is that talking about? The plane that's going with the wind. The with, I'll explain this in 1 second, but the with the wind is important. Okay, what else is important? 325 miles per hour, and what's important about that one, or what is that talking about? Into the same wind. And then what are we looking for? Whatever the question is asking, those are going to be your 2 variables. So if you aren't sure, always start there. That's going to be our 2 variables. So let's write that down and then we'll talk about what this is asking, what it's looking for. So we can call this P and W for speed of the plane, speed of the wind. Then there are a couple of things that you need to remember in order to be successful with these type of problems. If it's flying with the wind, so the wind is basically pushing the plane forward, you're going to be adding. If it's flying into the same wind, that means it's going basically against the wind that was pushing it, so now that wind that was helping is being subtracted. When you solve these type of problems, in theory, unless there was a tornado or hurricane, something major, the speed of the wind should be relatively lower than the speed of the plane. If you have a high speed of wind and not a high speed of plane, something should click that doesn't make sense. I have these backwards somehow. Right, so we have our variables. With these, the setup is very simple because we only have 2 numbers. Both of those numbers are your totals. So for the with the wind, we would do P plus W equals 369. That's it. What do we think the flying into the same wind equations would look like? Right. P minus W. Now be careful here. Because we're not doing the wind minus the plane speed. We're doing the plane minus the wind speed. So it's very important that you put this in a specific order. How do we want to solve this? By graphing, substitution, or elimination? You guys choose.
Yeah.
Substitution.
Which one?
Substitution.
Okay. So these problems work well with elimination, but substitution also works. So if we're substituting, it does not matter which equation, we just need to solve for one of them. I'm going to pick this one, and I'm going to solve for p.
Yeah.
So to solve for p, I'm going to add w to the other side. And substitute this into the first one. If you're running out of space or need more space, grab extra paper. So this would be 325 plus w plus the w that was already there equals 69. And solve. We have 325 plus 2w. Subtract the 325. I'm going to write this up here. 2w equals 44. And when we divide, what is the speed of the wind? 22 what? What is our label? mph, miles per hour. And we just need to go back and find p. Where you put this doesn't matter. I'm just going to put it here since we already have this set up. So p equals 325 plus 22. What is the speed of the plane? 357. What is our label? Miles per hour.
No.
347.
Yeah, it's like 47.
Yes. My bad. So these ones, as long as you know how to set it up, should be easy points for you. The solving is very simple. We're not adding in extra numbers. Do you have any questions about that? So all of the flying with the wind, let me say this. So in number 5, instead of with the wind, into the wind, it says with a tailwind or flying back into the same wind. It's basically the same thing. So with a tailwind would be like the wind is pushing it. And then back into the same wind, you would be subtracting that. Right? So there's the wind problems, and then there's current, speed, river problems. So let's do one of those. So number 2. Going down a river, a boat with 13 kilometers per hour. Going up the river, it only went 3 kilometers per hour. What is the speed of the current? How fast would the boat go if there were no current? So what's important there? Right, down a river, 13 kilometers per hour. Speed is current. How fast? So, just so we're all on the same page, when it's talking about the current, it's talking about the river. The flow of the river. So when it says the speed of the current, it's talking about the river's speed, or the current's speed. Either or, you can write that either or. So I'm going to call that C, and I'm going to put current, but then in parentheses I'm going to put river speed. So we know that's what it's talking about, not like present day speed. And then how fast would the boat go if there were no current? This is asking for the boat's speed if the river is not moving. I'm going to call that B for boat speed. Okay. Something else. We may know this, we may not. If we're going down a river, the current is helping, it's pushing, so you're going faster. If you're going up the river, it's opposite. So down a river, you would be adding. Up the river, you're subtracting. How would I set up these two equations? It'd be very similar to the last one. What equals 13? Sorry, I missed the first one. B plus C plus B, doesn't matter, yep. And then how would we set up the second one? B minus C equals 13. Same thing here. We're getting rid of the help that the river was helping us with. So we're subtracting the current, the river speed, guys, not the boat speed. Right? How do we want to solve this? Substitution, elimination, graphing. Okay. So substitution is going to look very similar to what we just did. Let's say I do the same thing here. I add C. So I have B equals 3 plus C. And then I take that equation and I put that back into the original where B is, back into the other equation where B is. So then 3 plus C plus the other C equals 13. And solve for C. So 3 plus 2C equals 13. Get rid of the 3. So that the river speed is what? 5. What is our label here? Kilometers per hour. So they won't all just be miles per hour. So take note of that. And then these numbers are smaller, so we can easily subtract. But if this was 13, or if I add, what is the speed of B? 3 plus 5. 8. Wording, like in number 4, it says traveling with the current, so it's helping it, it's pushing it. Against the same current, it's being subtracted, it's being taken from it. Do we have any questions on how we solve our word problems? No one asked to do a problem by graphing, but that is also an option. Do we have any questions on how to set these up, how to solve them, get the answers, label? So in about 10 minutes, I'll let you get your phones back. But right now, I want you to practice either in this or on Delta Math. You do have a Delta Math on this that's due next week. You also have one that's due tomorrow on elimination if you haven't already done it. Slash the ones that were due last week if you still need to do those. So work on Delta Math or this.